welcome back. In this video lecture we are going to talk about a basicity of amines. Before going into the factors influencing the basicity of amines, first we should understand in which part of the amine structure is responsible for a basic. Okay, now let me start with this simple structure as RNH2. So this is a primary amine, and this nitrogen is having lone pair electron in the presence of some acidic condition. So this lone pair electron is going to take this proton. According to Lowry-Bronsted acid base theory, that base can accept a proton. Okay, now after that what will happen? This will get the positive charge. So this is how the amines, the lone pair electron of the nitrogen is responsible for the basicity of amines. This is the fundamental thing. First we should understand it. Okay, the lone pair electron of the nitrogen is responsible for the basicity of amines. Now we start the factors affecting the basicity of amines. Here we listed a total 4 factors: inductive effect, solvation and steric, and third resonance, and the last is hybridization. First we start the inductive effect. In the previous lecture, the topic of that acidity of phenols, we learned certain fundamentals like some groups, electron donating groups and electron withdrawing groups. In general, always the electron donating groups increases the basicity. Okay, that we should always remember. And electron withdrawing groups, it will increases the acidity. So this is the fundamentals, the basic things we learned. Now in the inductive effect, if you take some examples or compare like this is a primary amine, that R is an alkyl group. Okay, and this is your secondary amine, and this is a tertiary amine. Okay, now you see here that R group is gradually getting increased. In the tertiary we are having 3 R groups, that means more electron donating groups. If we are having more electron donating groups, what will happen? According to this theory, it will increases the basicity. Definitely compared to the secondary amine, tertiary amine will have the highly basic in nature. So finally, so we learned that inductive effect. So this is the order. Okay, the tertiary amine will be highly basic in nature, followed by secondary, primary and ammonia. Okay, next we will move to the solvation and steric effect. In the solvation, what we should understand is, first it is going to be in the some aqueous condition. Let me take this example, some primary amine I am taking it. So this is RNH2. Okay, and if you react in the presence of acid in the water, so what will happen? So this I have written here. Okay, so first it will form here this like this. Okay, now you have to listen very carefully. You see it forms like this structure, and whatever this hydrogen group, that atom is forming a hydrogen bonding with this water molecule. Okay, you see like this, there is a formation of hydrogen bonding between this ionic species and the solvent. This will increase the solvation. Okay, the maximum, you see here there are 3 water molecules are involved in the solvation of this cation, and here in the secondary amine you see there are increasing of 2 R groups. Here there are 3 R groups. That means the solvation getting reduced by the formation of hydrogen bonding. Here it is very lesser hydrogen bonding. As a result, this primary amine will be highly basic in nature than a secondary and a tertiary. So that means the order will be primary will be highly basic, then secondary, then tertiary. Please remember that in the previous case with the inductive effect, tertiary, secondary and primary, then ammonia. Here you see totally reverse. The primary will become a highly basic than secondary than primary, because here the solvation is getting reduced when this ionic size is getting increased. You see there are 3 R groups, that's why there is a lesser hydrogen bonding. That's why these were not able to getting stabilized by the water molecule. As a result, it will getting decreased. That's the reason the tertiary amine is a weak base in the aqueous condition. This is in the aqueous condition. This order is in aqueous condition. Then what about in the previous case? That means this is in the gaseous condition. Okay, these are in the gaseous nature. So these are about the solvation effect, and we are going to see one minute, that is very important information, the steric effect. Now listen carefully. This R group may be anything. If the R is, let me take 2 R groups. One is R is methyl and another is ethyl. As we know, this ethyl will be the bigger one and the methyl will be the smaller one. When we change the alkyl size, the size of the alkyl group, how the basicity is going to affect. Okay, now it's the same thing. You see here that methyl, dimethyl amine, here this is the primary amine, this is methylamine, this is a tertiary methylamine, and this is the ethyl one. If you see their basicity, you see, and here the secondary amine is getting highly basic than the primary one, then tertiary one, then ammonia. You see the order is secondary amine is greater, but you see when the R group has been replaced with ethyl, you see there is a completely difference. But what we learned in the solvation effect, the primary should be greater than the secondary than tertiary, but you see here the order is totally changed, because the size of the alkyl group also playing some important role in the hydrogen bonding. You see, if that the size of the alkyl group is getting changed, that hydrogen bonding will getting affected, then as a result the solvation also will get disturbed. As a result, the basicity order changed due to the size of the alkyl group and especially the steric effect. Okay, you see here I have given the pKa value. Here this is 10.73. Please remember that higher pKa value means that is highly basic in nature. So in conclusion, in solvation and steric effect, that hydrogen bonding is also affected by the size of the alkyl group. Okay, that we should remember. And third one is a resonance. In the resonance, what we are going to learn is we are going to compare two amines. One is aliphatic amine and second is aromatic amine. So this I shown here, one methylamine, this is an aliphatic and this is an aniline, aromatic amine. You see, this aromatic amines are weak base and these are strong base. The reason is, here we know that this lone pair electrons are responsible for to attack the proton. But in the aromatic amines, what will happen is this lone pair is involved in the resonance. As a result, this lone pair electron is not available for to attack immediately the proton. So you will get like this. Okay. Like this. So this lone pair is involved in the resonance in the aromatic amine, but in the aliphatic amine, this lone pair is not involved in the resonance. It is freely available to attack the proton. That's why these are acting as a strong base. Okay. So aliphatic amines are stronger base than aromatic amines. Next, we are going to see the last factor is hybridization. Okay. Now in the hybridization, we are going to take some three different that nitrogen compounds here. So this is the hybridization of this is sp3 hybridization of nitrogen, and here the nitrogen hybridization is sp2. Okay, I already given one this how to find out the hybridization of any particular atom, that I given in the description link. Please go through it. That is very easy to find out. Okay, so this is an sp hybridization of nitrogen. Here all are, I am talking about the hybridization of nitrogen. Okay, so you know how to calculate the s character of this sp3. Here s is 1 orbital, there are 3 p orbital, that means total 4, that means 1 by 4. If you want to calculate the s character of this sp3, that means this is 25%. Okay, and this is 1 by 3rd, that is this is 33%, and this is 50%. This is the nature of s character. Please be remembered, when the s character is getting increased, that means that acidity will get increase. Okay, increasing of s character, that means increasing of acidity. Decreasing of s character, increasing of basicity. Okay, so here which one is having less s character? So this is having less s character, this sp3 hybridization. That's why these are highly basic in nature. For example, this pKa value is 10.75, and this is 5.25, and this is minus 10. You see, this is having higher pKa value. That's why this is highly basic in nature. Okay, so in conclusion, the lone pair electron in the sp3 hybridization are easily available to attack the proton, but not in the sp2 and sp hybridization. That's why the sp3 nitrogen is highly basic in nature. Okay, I hope you understand this basicity of amines. Kindly subscribe and share it if you find this video lecture is useful. Thank you very much.